Alright, we got the man observing a rocket scenario. Here we go. Related rates. Woo woo. A man observes the launching of a rocket from a distance of 300 feet. Alright, let's draw a picture. I like drawing pictures. It helps me visualize. Alright, so here's this dude. Oh, way big. Too big of a marker. There's a dude right here. And there's a rocket, like, up here. Let's try to draw this rocket here. Can I draw a rocket? No. Maybe I could draw a rocket. That looks like a rocket? Does that look like a flame? I don't know.
That's a rocket.
Guys, give me a break. 300 feet away from the rocket. Okay, there it is. Now, if you guys are having a hard time understanding what these problems say, don't forget what I talked about. Identify the numbers by circling them and underline math words. The rocket is launched at a speed. Hey, in calculus, speed is a really important math word. That's known as a rate. You know, if it said slope or rate, same thing. A speed of 100 feet per second. To represent that on my picture, I guess I'll do 100 feet per second. And I'll put a little arrow saying that's the direction that it's going. All right, so this distance is obviously changing, so it needs a variable. I want to use y just because y is usually the one that we use to measure a vertical distance. All right, let's read this next question because we don't have a goal yet. How fast, whoa, fast? Fast is a rate. That's a rate word. How fast is the rocket moving away from the man? How fast is the rocket moving away from the man? 4 seconds after the launch. All right, so that's the question there. So we want to see how fast the rocket is moving away from the man. Okay, now let's think about this very quickly. Now this is moving up. This movement right here is moving away from the ground, right? Which is causing this distance right here to change. This distance is the distance that the rocket is from the man. Alright, so let's give this one an X. Since the rocket is going up, that is changing Y and it is changing X. Those are the two values changing in this scenario. Is 300 changing? So what's the rate at which this number is changing? Yeah, you just said that it wasn't changing, so what's the rate of it? 0. So that means we can plug 300 into whatever we get. Well, we'll talk about that in a second, I suppose. How fast is the rocket moving away? So what's our rate that we're looking for? dx over dt. Because that would be the rate at which this distance right here is increasing. So do you guys know of an equation that would relate all these numbers together for this related rates problem? I see a right triangle. What about you guys? Sure. Let's use the Pythagorean Theorem. We have x squared plus y squared equals... No, that's not right. That's not right. It's y squared plus 300 squared equals x squared. Okay. So there's our relating equation. We got to take the derivative of this so we can get our rates in there. Alright, so we're going to take the derivative of this with respect to t, take the derivative implicitly. We drop the 2 on that y, and we take 1 away from the 2, so we just get 1 power. But then we have to multiply this by dy over dt, or also known as y prime, plus, and now, wait, what's this?
0.
That's just a number, right? And we said this earlier, what is the rate of that constant number? 0. And then we have this x, we gotta drop the 2, then we get dx over dt. Beautiful. Okay, now, my goal is to find dt. Now, in order to find dt, I have to have that variable, and that variable. Do we have all of those variables? Let's see. Do we have a dy dt? Yeah, that's 100 feet per second. Do we have a y? Nah. Do we have an x? Nah. Okay, so now, if you got stuck right here, this would be your question. Did I use all the important information that I circled or underlined? Let me see here. Oh, we didn't use this at all. 4 seconds, how would that affect my picture right here? Oh, it would affect y for sure. Why would it affect y? Oh, so 4 seconds at 100 feet per second would make y equal to 400. And that's a feet, right? 400 feet. So, oh, check that out. Check that out. Now we have a 300 or 400. Do you guys know what this x is going to be? That's going to be 500. If you didn't know that, you guys could use the Pythagorean Theorem to find that out, or look up Pythagorean triples, because we have a 3, 4, and then there's a 5. So now we have all those variables. We have the y, we have a dy dt, and we have an x. So we go about solving. Our y is 400. Our dy dt is 100. And then we have an equals. That 0 doesn't matter. Let's see, 2, and that'd be 500. And then dx dt is what I'm looking for. So on this side, the left side, I get 8,000. I'm sorry, 80,000. This side I have 1,000 times dx dt. And I divide both sides by 1,000 to get 80. Wait, I want to write it like this. dx dt equals 80 feet per second. Next, let's see here. Let's get a black pen here. We got how fast is the angle of vision changing at the same moment? Well, we got 3 angles, so let's try to figure out what the heck it's talking about. Is it talking about this angle right here? No. There's that angle or this angle. This doesn't look like an angle of vision. This one definitely would be. And now I want to talk about something that kind of annoys me. Sorry, this is a tangent. It annoys me that this triangle isn't right at his face, because it's talking about angle of vision, right? Because we should account for his height or something. You don't have to make this problem that complicated. It's not that. It's not trying to be that complicated. So I guess we could just change the guy. That would make me feel better. Let's just put this guy down here with his head. No, right here. There. He's looking up. There you go. All right. So that makes me feel better. There's the angle of vision. That's theta. Now, just like before, we found this equation right here, this Pythagorean theorem, to relate all the values together. What is the equation that we can use to relate theta to some of these other numbers? And do we have to relate it to all the numbers? No, just at least one of them with a rate that we know of. Now, I think I want to use 300 for sure, because the rate of 300 is 0, and that will make my problem easier, won't it? So this is the adjacent side to theta. What are the 2 trig functions that would use the adjacent side? Cosine or tangent? Now, cosine would be a good choice because you would do adjacent over hypotenuse. And you're not going to plug in 500, people. We're going to use x if you use cosine. Now, the reason why I wouldn't want to choose that is because now that I have an x in there, when I take the derivative of that, I'm going to get a dx dt. And our value for dx dt was found by us. And what if I got that wrong? If I got that wrong, I don't want to get this wrong. And so I'm not going to choose cosine. I'm going to choose tangent because this rate right here was given to me by the problem. So I know that number wouldn't be incorrect. So I'm using tangent. So we have tangent of theta equals 300 over y. I get the question all the time, how come you don't plug in 400? Well, because then you're taking away the y, and you wouldn't know the rate at which it is changing. I did that totally wrong, did I? Oh yeah, I was supposed to go y over 300. Oops. It's opposite over adjacent. Okay, so now when I take the derivative of this, I will get, as a result, a dy dt. All right, and then maybe if I still have a y, I'll plug in the 400. All right. So I'm going to take the derivative of this thing, but I'm not going to look at it like that. I'm going to take that y out of the fraction and put them in front. I can do that because the y is on top. So now 1 over 300 is a coefficient. I'm going to take the derivative of this with respect to t. If I take the derivative of tangent, that would be secant squared, and then theta. But we then have to do the chain rule and take the derivative of what's inside of tangent. What is the derivative of theta? It's just a 1. All right. We'll do that in a second. Let's do this one really quick. No, we'll finish that. All right, so the derivative of theta is 1, so we have secant squared theta times 1. And then because I'm taking the derivative with respect to t, I get d theta over dt. Now let's do the other side. What is the derivative of that? Well, the y just goes away, and I get 300. And then I have to multiply that by dy dt. All right, let's write that a little higher on the screen so you guys aren't trying to... All right, next. Man, this looks dirty. Let's clean it up just a little bit. We have secant theta. Now I'm going to take that squared and put them on the outside because I know that's easier for a lot of you guys to see. It was easier for me to see when I first learned this. And then this is going to be 1 over 300, and I know what dy dt is. That's 100. Okay, so I just plugged in dy dt. So let's see. I need to find d theta dt. That will tell me how the angle is changing. But in order to do that, I need to know what secant theta is. Oh, that stinks. But it actually doesn't stink that bad because you first thought we had to use a unit circle. But whenever you have the triangle, we can use the triangle to figure out this. Now, if you don't like secant, you can get rid of the secant and look at it like it's 1 over cosine theta, because that's what secant is. Secant is 1 over cosine theta. All right, but if you know what secant is, by all means use it. I just think it's more common for you guys to know what cosine is. So what is cosine theta of this? What is cosine of this angle right here? It'd be 300 over 500, which equals 3 over 5, right? Right? 3 over 5. So I'm going to write 1 over 3 over 5, and we're going to square that dude. And then we are multiplying that to d theta over dt, and on this side we now have 1/3 because I multiply the 1/3 by 100. All right, in here we have a 1 divided by a fraction. Whenever you divide by a fraction, you can think multiply by the reciprocal, or you can just multiply the top and the bottom of this fraction by 5. That would be cool too. So that means this would be 5 over 3. Let's see, let's get rid of that 5 there, put a 5 up there. So now I have 5 over 3 squared. What would that give me? 25 over 9. D theta over dt. I'm sorry guys, I write extra when I'm explaining things. And then I multiply by the reciprocal. So I'm going to multiply this side by 9 over 25, which would get rid of those guys. And then I'll multiply this side by 9 over 25. And then look, I could cross cancel with those 3's. Oh, that's beautiful. So d theta over dt equals 3 over 25. And what are my units? Radians per second.